Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Today, we are incredibly excited to welcome a visionary leader in railway technology, Vicky Alman, as the CEO of NIART Systems. Vicky is the forefront of revolutionizing rail safety and efficiency with cutting-edge radar-powered perception solutions. Her work with NIART is literally helping trains see further and clearer, regardless of the weather conditions, paving the way for a safer and more autonomous future in railway transportation. Vicky, welcome to the pod. Thank you for joining us.
Thank you for having me. I'm really excited to be here, Rahman. Thank you.
So let's start with your origin story. What inspired you to found NIART Systems and what gap did you see in railway safety and perception tech?
Well, actually, most of my career, I have been working in the aerospace industry. I was building airborne radars and space-based imaging systems. So sensors and sensor fusion and safety systems is actually my expertise and passion. I have seen firsthand how important it is to deploy intelligent systems to support critical missions and also to build them reliably, because in aerospace and defense industry, most of the time failure is just not an option. And why am I in railway now? Well, just think about air travel the last time you flew on a plane. It is so natural for us that pilots rely on systems that can see, alert, and act far beyond human vision. But on the other hand, in rail, where hundreds of passengers or high-value cargo is being transported by the trains, we still rely on the driver's eyes and his subjective interpretation of the scene. And NIART was founded exactly because of that, because rail deserve reliable perception and not subjective interpretation. Actually, fun fact, NIART is train spelled backwards. So we are rail first and rail focused from inception. And we see the technological gap. It is clearly there. This sort of technology is not available on the market, and simply borrowing from the automotive tech is not hitting the targets and the performance needed in railways. But when you come from aviation and from aerospace engineering, these practices are exactly what is needed to build the perception that the railways can rely on, can also take the rail into the future of automation.
Amazing, great stuff. I'm very keen into deep dive into NIART. So for our listeners who are new to NIART, what is your product and how does it change the way trains perceive their environment?
Thank you for asking. NIART Systems delivers multi-sensor, radar-powered obstacle detection systems for rail. Our mission is actually well defined. We help trains see in all conditions, fog, rain, snow, or darkness, so the drivers and automation systems can make better and earlier decisions. We build platforms that deliver long range, above kilometer detection, and do also robust tracking and sensor fusion, where we turn raw signals into actually actionable insights for the driver assistance of today, but also looking at the tomorrow's autonomy. Our team is actually experts from the radar domain and optics domains, coming from mobility and aerospace. We are pairing it with multi-sensor fusion, obviously adding AI to the mix. And we have been focused on the railway safety case from day one, meaning long-range detection, much longer than in the automotive, low false alarm rate because the cost of false positive is high, and flexible configurations that will fit various rail operations and various clients.
Wow, amazing technology. What does it do? So if it detects anything, so will the train gonna come to a stop?
The system that we are delivering is a perception system. So we are providing actionable insights and recommendations, let's say advisory to the driver today. We are not controlling the train. It will be the role of either the human driver or a future automation system. Our mission is to be the eyes and the brains, let's say, to support the decisions, but not to actually do them or control the train as a driver.
Amazing, amazing, Vicky. So let's talk more about radar first. So in rail, many talk about cameras and lidar. Why is radar powered perception fundamental for rail, especially in all weather, low visibility conditions?
Well, I think the answer is kind of in your question already. Cameras and lidars are valuable, and we actually incorporate them within our solutions. But radar is an instrument that is fundamental when you need 24/7 around the clock critical operation. It's not that it's better, it's just different physics. Radar penetrates fog, rain, and dust, delivers accurate range and velocity measurements, and maintains performance in any visibility. When you think of a train traveling for hours in pitch black darkness or thick fog, being able to safely maintain speed cannot depend solely on optics. We always use radar as the ground truth backbone, meaning it is our main detecting sensor, and then we layer cameras, LiDAR data for classification and context when it is possible based on the visibility. I think that, let's say, not like in the automotive sector, our economy needs trains to meet the schedule and keep on running constantly. So it doesn't matter if it's human driver or autopilot, we need them to run all year round, no matter what. And for that, we do need combined radars into the railway perception suite.
Amazing stuff. So, looking into the performance, so I just went through your website, NIART website, and found that radar powered long distance obstacle detection system is about 1200 meters. So, what does this actionable detection look like at that distance? And how do you validate real world reliability?
Well, actionable detection means that the system sees obstacle early enough to prevent an accident and does it reliably enough for the driver or the autopilot to actually act on it. When we provide detection at 1200 meters, we not only detect, we also add layers of information, which is, for instance, accurate range measurement, hazard level score, and we also are capable of distinguishing between what is in gauge or out of gauge hazard and whether it is in the path of the train or, let's say, on adjacent tracks or areas. When we work on our solutions, we verify our performance using multiple validation gates. It's controlled and recorded ground truth runs. It's maintaining confusion matrix targets for false positives and negatives, and to build systems that inherently have the capability of high fidelity scenario replays all the time for debriefing, debugging, interrogation, and improvement. I believe that unreliable alerts is not only noise. It can actually disrupt train traffic. It can waste energy. So we need to make sure that the trains operate with maximum possible efficiency and run around the clock with optimal speed, energy consumption, but without compromising on safety. And this is exactly what NIART is aiming for.
Amazing stuff. I really want to hear more about this technology. So, as you said earlier, all visibility and all weather conditions. Can you walk us through specific scenarios like a fog or a heavy rain, snow, darkness, where radar gives a decisive advantage over other sensors?
Well, I can give you just a few examples. Think of dense fog in winter corridors. Radar keeps on detecting and alerting even when optics and LiDAR are almost completely blind. When you imagine working during night in snow, the reflections and the blowing snow degrade vision significantly.
Yeah.
But radar maintains its resilience. Twilight sunbeams also, and passing through tunnels also struggle. It's a struggle for the vision or optics-based sensors. But radar is completely agnostic to these. So even going through these real-life situations, our ODS, obstacle detection system, will provide the best envelope of performance and will be stable and detecting the obstacles in the path of the train.
I got a follow-up type question, Vicky. So
Yeah.
if the operator has multi-sensor fusion and not just radar, so how do you fuse a radar with other sensors? Example like camera and lidar we just spoke. So what's your philosophy on this redundancy for safety critical systems?
Great question, Rahman. Well, actually, our philosophy when we build systems is maximum redundancy, minimum blind spot. Radar provides long-range detection, range measurement, and velocity. Cameras perform independent detection in parallel and add classification and visual context. LiDAR in our system refines near-field geometry, but also supports shunting yard operations like coupling. We use INS, GPS, and geographic data to enhance accurate localization. And we fuse this information on multiple levels. Some of them on the signal level, some of them on the object, and then on decision level, so that no single sensor is a point of failure. The resulting system is resilient, provides graceful degradation, and is aligned with Steel 2 system concept. And this is something that, let's say, single modality systems will struggle to achieve.
Amazing. So before even you go on site, do you do any type of factory testing, lab testing?
Absolutely. The systems go through various phases of testing. It is, first of all, obviously lab testing, then it's field testing in static mode, then we go on driving mode. We have vast recording capabilities so that we are capable of replaying and injecting raw data signals through our system to, if we get 1 hour of drive on a railway platform, we can use the same recording for 1,000 times to do regression tests and performance tests while we are in our office.
Amazing. I got a quick question. We just spoke about that this system can be used for drivers or even for autonomous trains. So my question in regards to that, NIART positions obstacle detection system for today's driver assistance and tomorrow's autonomous operations. So what milestones mark that transition?
That's kind of a difficult question. Well, when you first come into, let's say, a market or an industry, you get so inspired by, the gap that you see and the things you can do. But then over the years, you understand how the industry works.
Yeah.
And especially railways, the baby steps that this industry is taking towards automation and let's say maybe I'm pessimistic, but a bit slow pace of bringing new tech into this industry. So we are realistic and we are pragmatic. We know that nowadays the train operation, at least on open main lines and shunting yards, is mainly manual. So we propose the system and we bring our first offering to this industry as a driver assistance. We will provide the situational awareness, the hazard alerts, the speed advisories, not controlling the train. And then once the systems are matured and the operators gain the confidence, we can graduate to, let's say, supervised automation in maybe controlled domains, like when you go for shunting or stabling. And ultimately, we aim towards ATO, full autonomy, in defined corridors or throughout the rail operation. But it will take time.
It does.
So the milestones, at least for us, is to gain enough evidence and real track experience so that we can show proven safety improvements. In parallel, to build our systems so it's seal aligned for hardware and software maturity. And the very big milestone for us will be to integrate NIART's system with signaling and ATO systems as the must enabler for the future automation.
I wish you would get to that place very soon. Before that, let's do a case study. So from your website, what I have learned that from deployments, you did deploy with Indian Railways in extreme fog and with Alstom on shunting and mainline automation. Any surprises from field trials?
Yeah, thank you for the question. Actually, it couldn't be more different, or let's say at the opposite edges of the rail operation, these two projects that you mentioned. With Alstom in Europe, we worked on fully autonomous grade of automation level 4 shunting operation, where we combined our perception system with Alstom's autopilot control box. The surprise for us actually was the insane overload of missions and tasks on the train driver. But on the other hand, also the understanding of how many of them can already be offloaded using the technology we already have today. In Indian Railways, on the other hand, it's not about automation. It's about assisting the driver, or what Indian Railways call train pilots, when visibility drops to basically zero during the winter season. And over there, we are focused on long range driver assistance system that provide early hazard cues at level crossings, at animals, and for static obstacles, while keeping the driver workload low and minimum of false positive. In this project, the interesting moment was the handover trust, I call it. The moment that the operator, the train pilot, starts to believe the system, starts to believe that the system can see when he cannot. We had to do a lot of work there. We had to improve classification and tracking. We had to add customized decision layers so that we are able to cut all nuisance alerts, because the railway scenery in India packed with life going on around and on it.
Yeah.
And we also, to enable continuous improvement for all the different edge cases, we also had to add forensic grade logging so that we are able to analyze and interrogate every single edge case that we encounter, and we are doing that offline while the systems keep on running.
Amazing. I think so far we've discussed about the technology and the trials. Let's talk about regulation and certification as well. How do you approach standards, safety cases, and SIL targets in railway environments when introducing frontier perception systems?
Look, we know that, same as for aerospace and aviation, no system can be introduced into this industry without being compliant to the standards that needed there. So when we started to design the systems, one of the first things that we did was to understand what are the standards that we need to comply with. So we build our systems with compliance to, if you're familiar with EN 50155 and other related standards. And as we speak, we are actively pursuing SEAL 2 level certification. We are working with TÜV Süd in Germany on the safety assessment these days. And every time we go on the tracks, we maintain a living safety case evidence. We are managing the hazard logs. We are doing FMEAs. We are logging traceable requirements, and we are constantly maintaining extensive real-time and back-office diagnostics monitoring. When we get this package of evidence, this is the information and the data that will allow us to get certified, will allow us to give the confidence to the railway operators that the system can help them and benefit them. We know that perception in rail is maybe a new tech, but the existing safety discipline, for us, it's not an option, it's a must.
Amazing. So what is this EN standard you just referred, EN 50155?
Yeah, this is like the, let's say, summary or the overall most complete standard for railway systems that mentions everything and also refers to other standards. But it's actually for everything, for environmental conditions and EMI and you name it. And there are several more specific for the sensors that we are using. And it is almost like military standards, I have to say, and some points even harder to achieve. But when you design the system keeping that in mind from the beginning, then it's much easier to get to that point.
Amazing. I'll have a look because I'm not aware of this. I do refer Senelec standards 50126, 28 and 29, but this is new. After our pod, I will have a look at it. Thanks, Vicky, for sharing. Let's talk about integrity and scalability as well. You offer end-to-end solutions as well as a radar as a service. Now, how do rail operators choose, and what are typical integration timelines?
Thank you for asking. Well, operators, we basically are offering for operators, they can choose from end-to-end solution, meaning we are bringing the sensor suite, the computing, HMI, doing the maintenance, or they can go for radar as a service, what I call, is when they want to tap radar perception via defined APIs into existing sensor suites and back offices they may already have. The radar is actually the game changer here. It's a unique railway-centric instrument and truly the only one on the market. So if you are an operator and you already have maybe lidars, cameras, or any other sensors, but you don't have radar, we are capable of bringing this radar, integrating it, and providing you instant value the second we install it and connect.
Amazing. So let's talk about return on investment. So I am the operator, I choose you. So where do railways see the fastest payback? Whether it is in accident prevention or downtime reduction, throughput improvements or maintenance optimization?
All of the above, Rahman. Well, the fastest payback obviously comes from preventing accidents and near misses, usually on main lines where it stops the movement, it damages the rolling stock and the infrastructure. It's also the downtime reduction from, let's say, smaller or fewer operational incidents, not necessarily accidents. So this is on the side of, preventing things and reducing damages. There is also an expected gain in capacity from being able to operate continuously, even in low visibility, and being able to improve energy efficiency thanks to optimized speed profile. I mean, if we can add even, few kilometers per hour to a speed of trains in harsh weather conditions, or save even 2% of energy consumption because we prevent unnecessary braking and acceleration, it is already a huge impact on the bottom line for the operator. We also, the more we work in this industry, the more we understand that there is also an added benefit to include advanced offline analytics using our data, analytics that is able to flag environmental risks and also pinpoint them to the exact mile so that the operators can take swift and effective action immediately. And when we look at the long-term payback, obviously it's enabling of higher levels of automation, offloading the driver tasks, maybe optimizing the manpower cost, and eventually moving towards full autonomy. And this is what I envision for our future railway.
Hopefully, and then let's talk about localization and work share. So NIART mentions teaming and knowledge transfer. How do you structure local content and offsite programs without compromising quality?
I think the best possible business model we can work with is finding local partners to be the boots on the ground and the customer facing. We prefer to partner locally for installation and operation and the full life cycle support. If I can define our strategy is bring in industry native local partners for customer success, but do engineering centralized in-house for safety and redundant and robustness of the system. So when we work with these partners, we transfer methods, we provide test tooling trainings, we also transfer knowledge and data governance. And this way we create a win-win teaming framework, both for us, for our partners, and obviously for our customers.
Wow, I really like it. So let's talk about the future. So what's on NIART's roadmap? Longer range, better classification, predictive analysis, or new use cases like yard operations and level crossing safety?
Good question. There are so many things on the roadmap, but I would maybe address the biggest one. Our focus and my focus specifically right now is on growth. We need to work with train operators to install as many systems as possible on existing trains today to be able to build a safety case and build confident adoption. We are currently working to embed our sensors in the future models of locomotives that undergo design as we speak to provide the competitive advantage of safety and deep tech to the OEMs that are manufacturing the rolling stock. We are expanding our footprint and partnership with tier one companies that need to expand their portfolio and upgrade their offerings. And in parallel, yes, we are doing some engineering also. We are adding new cases to the mix. For instance, autonomous platforms for the first and last mile that are currently running in the US and or at least being built in the US and Europe. And also what I mentioned before, the environmental monitoring that will surface risks and things that are happening around the tracks or around the corridor and to spotlight them before they actually happen. We are not in this business because we love sensors and we are not doing sensing just for the sensor's sake. We are using our sensing expertise to ensure reliable and safe railway operation, regardless of visibility, to provide the reliability needed for 24/7 operation.
Amazing. I really like your concept. So I'll ask a leadership question and also an advice. So you as the CEO, how do you balance this deep tech research and development with the operational rigor rail customers expect? And what advice do you have for innovators in safety critical mobility?
Well, I am an engineer, and I have been working as an engineer for many years. So technology is amazing thing for me. But along the way, I learned that innovation and technology is not the goal. It's just the means to an end. Since even my early career days, I have always looked at the business case and what can provide the best value for the customer. So it's not about doing technology and then saying, hey, try and find what it can do for you. No, it's first looking at what needs to be solved and then find the technology to do it. In every system design and throughout NIART development process, for me, there are always two non-negotiables that I never compromise on. First is bring me evidence over hearsay, meaning every claim, every issue, every bug, every problem, every edge case, we need to trace it to data and being able to do high fidelity tests to prove that we have solved it. And secondly, it's flexibility over data sheet. I don't believe there is a single solution that fits all.
Yep.
We design the system in a modular and flexible way, and then we work with our customers to tailor the best offering for their specific pain points. And this is exactly my advice to innovators or people starting to run new developments. Don't assume you know it all. Learn your industry pain points. Focus on those pain points that you are capable to solve based on your unique expertise. Don't go the other way around.
Great advice, Vicky. But I got some few rapid questions for you. One myth about autonomy in rail you would like to debunk.
I think the largest or the biggest myth is it's not the technology that is blocking it. The technology is here. I think it's the alignment between regulators and operators. If they only decide to do it, join forces, set their mind to it, it's a near future reality, not a fantasy.
Next, a metric you are most proud of from NIART deployments.
Well, I don't know if it's a metric, but it's a real life case. We were able to prevent a suicide attempt while being in India in thick fog. The train was able to brake due to our, or let's say the driver was able to brake the train in time thanks to our alert, and life was actually saved.
Wow. Thank you. Thank you. Really, thank you. You made us proud. What would accelerate adoption most? Standards, regulation, or demonstrated return on investment?
Well, all of the above and more. I think you nailed it all. It has to come combined together. ROI will drive the change, but railways will never adopt technologies that is not regulated. I envision networks where trains are routed intelligently and running with optimal energy profile and reduced emission, and all of this is communicating together. But it has to come from the push has to come from the top, from the regulators and from the operators. And realistic KPIs and requirements has to be set so that the industry can actually meet them.
Amazing stuff, Vicky. I didn't know how the time passed. I learned a lot from you by talking, and I hope even my audience have a lot to take away from this pod. Thank you for joining and sharing your insights with us.
Thank you. Thank you for having me.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry, contact me on railway transportation systems at gmail.com. Thank you for your time today. Stay safe and take care of yourself.